Hello everyone, welcome to Wanies Academy, and today we're talking about cracking and alkanes under the subject chemistry. So let's look at the aim of the lesson. The aim is to help you understand what cracking is, why it is important, and to introduce alkanes as useful products of the cracking process. And at the end of this lesson, you should be able to define cracking, describe how cracking is carried out, state the general formula and structure of alkanes, also mention some uses of alkanes. So let's dive into the lesson. What is cracking? Cracking is the process of breaking down long chain hydrocarbons from crude oil into shorter and more useful molecules. So crude oil naturally contains many large alkanes that are not really useful. We can't use them in that form because they are thick and they don't burn easily. So to use them, to make them more useful, we have to crack them into smaller hydrocarbons, just like how you crack your biscuits into smaller ones. So these smaller hydrocarbons include shorter alkanes, which make good fuels, and alkenes, which are very important in the chemical industry. For example, we have decane, which is C10H22. Decane is a long hydrocarbon. It is a long alkane with 10 carbon atoms. So we're going to use line to indicate our hydrogen carbons, which are 22 altogether. So alkanes and the longer or the higher hydrocarbons in this form, we have decane, is broken down into smaller hydrocarbons. So decane is broken down into octane and ethene. It is broken down into octane and hexane. Octane is C8H18. C8H18. And ethene, which is C2H4. Now you need to note this. Whenever cracking is being processed or whenever we crack a large hydrocarbon, the product and the reactants have to be the same in the sense that the carbon atoms of your product has to be the same with the carbon atoms of your reactant. Just like the cane, we have 10 carbon atoms. Then in octane and ethene, we have 8 carbon atoms from that of octane and 2 carbon atoms on that of ethene. So when we sum this up all together, it gives us 10 carbon atoms. So the atoms of the reactant and the product have to be the same during cracking. So cracking breaks down. In this case, we have decane. Decane is broken down into a smaller hydrocarbon, which is octane and ethene. So cracking can be done in two methods, which are catalytic cracking and steam cracking. Catalytic cracking is when alkanes are heated over a high temperature of 500 degrees Celsius to vaporize. So when this is vaporized, it is passed over a hot catalyst. In this case, we have aluminum oxide, which is a catalyst. Then the other one is steam cracking. In steam cracking, alkanes are heated to vaporize. So when they are vaporized, they are then mixed with steam and heated again in a very, very, very high temperature. So these two are different methods. They are the two methods of cracking. So why do we crack hydrocarbons? One, to produce more useful fuels like petrol, like diesel from less useful heavy fractions. So since we said we can't use the heavy fractions like that, they are a less useful ones. So we break them down to create more useful fuels like petrol, like lubricating oil and others. Also, we break down hydrocarbons to make alkenes, which are used to make plastics and other chemicals. Your polythene bags, your poly bag, which is polythene bags, are also gotten from alkenes. So we also crack hydrocarbons to meet demand. When we say to meet demand, as we know that The lighter ones, the shorter alkanes are more useful. So since they are more useful, they are the ones that are in demand. The lighter fractions are always in demand because they are more useful. So cracking helps the oil industry balance supply and demand. So with that being said, let's look at alkanes. Alkanes are homologous series of unsaturated hydrocarbons. When we say unsaturated hydrocarbons, they contain at least one double bond. Example here we have ethene, like we said earlier, ethene. If you have to draw the structure of ethene, it is C, a double bond, and C. So alkanes generally have a double bond, at least one double bond. So that is why they are unsaturated hydrocarbons. And they have a general formula of CnH2n. For example, if our n equals 3, we're going to substitute 3 for n whenever we see n. So it becomes C3H2n to give us C3H6. So alkenes have the general formula of CnH2n with examples as ethane, propene. This is propene, C3H6. Then we have butane, which is C4H8. So the double bond makes alkene more reactive than alkane. Alkane is a saturated hydrocarbon. That's the one we drew earlier, which is decane. We have decane, we have octane. If you notice, they all have single bond. So that is a saturated hydrocarbon. But because of the presence of double bond in alkene, it is more reactive than alkane. And they also decolorize bromine water from orange to colorless. They remove the color of bromine water from orange to colorless, and that is how to test for the presence of alkanes. So let's look at the uses of alkanes. Alkanes are key raw materials in the petrochemical industry. They are used to make plastics, they are used to make detergents, ethanol, and many other chemicals. So alkanes are very useful in the chemical industry. So even though they are not good for us, they are very, very essential for making everyday materials. So we've come to the end of today's lesson. Thank you for watching, and don't forget to like, share, and click the subscribe button.